For this problem, we're going to graph a system of inequalities. We want to graph this system of inequalities, then we're going to tell whether the graph is bounded or unbounded, and we'll label all the corner points on our graph. We have four inequalities in our system: x greater than or equal to 0, y greater than or equal to 0, x plus 2y is greater than or equal to 8, 2x minus 3y is greater than or equal to 2. Because we're going to graph this, we're going to go ahead and make a grid off to the side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we're going to use a scale of 2, so each tick mark represents 2. So here we'll have 6 and 12, and here we'll get 6 and 12. We're going to start off with our first inequality and treat each of these as an equation. So we'll say x equals 0. So we're going to graph the line x equals 0. That's a vertical line which corresponds to the y-axis. X greater than or equal to 0 means that we're at this on the y-axis, or we're to the right of it, so we're over this way. Our next inequality, y greater than or equal to 0, we'll graph the line y equals 0, which is the x-axis. We want to be greater than that as well. That puts us above this line. Using these first two inequalities, we see we're focusing on quadrant 1 and the coordinate axes. We're going to move on to our next inequality. X plus 2y is greater than or equal to 8. So again, we'll treat that as an equation. Set that equal to 8. And we're going to solve for y. So 2y is negative x plus 8, or y is negative 1/2 x plus 4. Our inequality is not strict, so we're going to graph the line y equals negative 1/2 x plus 4 with a solid line. We need a couple of points, so we'll go ahead and let x equals 0. If we do that, we get 4. We get this point right here, 0, 4. If we let x equal 4, 4 times negative 1/2 is negative 2. Negative 2 plus 4 is positive 2. So we go over 4, and we'll go up to 2. Go ahead and connect our 2 points. And there we have the graph of negative 1/2 x plus 4. Now we have an inequality, so what we have to do next is decide where we need to shade. The line y equals negative 1/2 x plus 4 divides the xy plane into two half planes. The half plane above the line, the half plane below the line. To determine which of these two half planes we shade, we're going to go ahead and pick a test point. We're going to use the point 0, 0 at the origin, since it's not on our line. If we plug in 0, 0, we'll get 0 plus 0 is greater than or equal to 8. Since 0 is not greater than or equal to 8, that's a false statement, we're going to shade the half plane that does not contain 0, 0. So we're going to be shading above that line. Next, we'll look at our last inequality. 2x minus 3y is greater than or equal to 2. We'll again treat that as an equation. 2x minus 3y equals 2. Solve for y. Negative 3y equals negative 2x plus 2. So y is equal to 2/3 x minus 2/3. The inequality is not strict again, so we're going to graph this line with a solid line. We need to get and pick 2 points. We might go ahead and pick 4. If x is 4, we'll get y is equal to 8/3 minus 2/3, which is 6/3, which reduces to 2. So at 4, 2, we get this point right there. If we go ahead and pick 6, 6 times 2/3 will give us 4. 4 minus 2/3, 4 is roughly 12/3. We're going to get something at 10/3, which is a little bit bigger than 3. So at 6, we're going to go up slightly bigger than 3. Should put us about right there. Connect our points. And here we have the equation for y equals 2/3 x minus 2/3. We again need to determine which half plane we're going to shade. This line divides the xy plane into two half planes. We're going to use our test point 0, 0 again because it's not on the graph of this line. We'll get 2 times 0 is 0 minus 3 times 0. So this left side is equal to 0 still. 0 greater than or equal to 12 is a false statement. So we're going to shade the half plane that does not contain 0, 0. So that's shading below that line. Now, the solution to the system of inequalities is going to be where the overlap is in our shaded areas. Remember, we're focusing in on quadrant 1, and we're looking for the overlap of these two remaining shaded areas. So we can see that our solution set will be in this region right here, and these graphs continue on forever. So the graph will keep going out this way, the overlap region will continue to extend that way, and so this graph is unbounded. There is no bound on the outer part. The corner points, we'll get one corner point right here. That was the point 4, 2. Another corner point will be where this line hits the x-axis, because that was one of our boundaries from our inequalities. And this point right here is the point 8, 0. This shaded region, the overlap shaded region, extends out this way. Make sure that we realize that the solution to our system of inequalities is where the complete overlap region lies. That's for all the inequalities. Our first two inequalities told us to focus in quadrant 1, so even though we see that the red and the blue shaded area do overlap down here, that doesn't satisfy our first two inequalities together, which puts us in quadrant 1. So we need to make sure that we focus on this region here that continues out, but we don't go below the x-axis.